Hello and welcome back to Higher Maths Differentiation. In Lesson 2, we are going to look at some more differentiation, more practice at differentiating. But this time we will need to get the given function into a suitable format so that we can differentiate it. So in Lesson 1, and I'm assuming you've done the work, you'll have had a bit of practice at differentiating. So in every question in Lesson 1, it was in a suitable format to differentiate. We didn't need to do any manipulation beforehand. In lesson 2 here, we will need to do that algebraic manipulation first. So it's important that before you differentiate, all brackets are multiplied out and there are no fractions with an x term in the denominator. So if we are going to differentiate, we cannot differentiate if there is an x term on the bottom of the fraction. Okay, so this is where all our essential skills in maths practice that we done before the course comes in very, very, very handy. So this is why we set the work for you guys. So hopefully you've remembered that. If not, go back to your essential skills in maths and just retry some of the questions. So if we have 1 over x cubed, we must bring that up and make it x to the power negative 3. Or 3 over x squared would be 3x to the power negative 2. 1 over root x would be 1 over x to the half, which would be x to the negative 1/2. This is a good one. This catches people out. 1 over 4x to the 5 is only the x to the power 5 that we rewrite as x to the power negative 5. This 4 stays on the bottom of the fraction, so it'll be 1/4 x to the power negative 5. And in a similar way here, 5 over 4, so it would be 5/4. And then the cube root of x squared, well, the power is the top number, the root is the bottom number on the fraction. And as it's on the bottom of the fraction, when it comes up, it'll become negative, so it'll be negative 2/3. Again, the 2 is because it's x squared. The 3 is the denominator there, is because we're doing the cube root of x squared. So let's have a look at a couple of examples. Differentiate the square root of x with respect to x, where x is greater than 0. Again, why does it say that? It's because we can't square root a negative, so this question will not work with the negative values for x. So that is just there to make the question mathematically correct. So notice the notation, d by dx of root x. I'm not told it's f of x equals root x or y equals root x, but I am told to differentiate. So d by dx of root x. So I need to make root x into a fractional index, into a fractional power. So that becomes d by dx of x to the half, using our National 5 indices rules, and knowing that the square root of x can be written as x to the half. Now it is in a suitable format, so power to the front, reduce the power by 1. Now because I started off with a square root rather than a fractional power, I'm going to return my answer into that format, because that is what a good young mathematician would do. So I have 1/2 multiplied by, well, x to the negative 1/2 means 1 over x to the half. So I have 1 multiplied by 1 over 2 multiplied by x to the half, or 2 multiplied by root x, so it'll be 1 over 2 root x. Question number 2, we have y equals 1 over x squared. Find dy dx. So again, right, 1 over x squared is x to the power negative 2 using our National 5 indices rules. And then say that we're differentiating, so dy dx equals power to the front, reduce the power by 1, negative 2x to the negative 3. Now again, I have started off with a positive power of x, so the negative 2 will stay on top of the fraction, the x to the negative 3 will become the denominator, so I have negative 2 over x cubed. Question 3, differentiate 2 over x cubed with respect to x. So again, I'm just told to differentiate, so I'm saying d by dx. I cannot just write 2 over x cubed equals negative 6 over x to the 4, because that does not make any sense. So I'm saying I'm going to differentiate. I'm then bringing the power of x cubed up, making it a negative power. So d by dx of 2x to the negative 3. On this line, I am actually differentiating. So the d by dx goes, so negative 3 multiplied by 2, so negative 6, reduce the power by 1, x to the negative 4, and make x to the negative 4 the denominator, so negative 6 over x to the power 4.